talk about adding, subtracting, and multiplying polynomials. So first of all, it might be a good idea to just kind of remind you what like terms are. So like terms are any terms where the variables and exponents on the variables are the same. And the thing is, they have to be exactly the same. So for example, here 3x squared and 2x squared are like terms because the x squared and the x squared are the same. Just like here, xy squared and negative 4xy squared, the x is the exact same here, the y squared is the exact same here. So because they're exactly the same, they're like terms. But here, for example, 2x squared and 2y squared, well, you can tell x and y, those are different types of terms. The variables are not the same. So the exponents, even though the exponents are the same, it's not like terms. And here is another example, xy squared and negative 4x squared y. Well, notice the variables are the same, x and y, but here, this one is to the first power, this one is to the second, where with the y's, this one has the second, and this one is just to the first power. So they're definitely not like terms. If this was xy squared, like in this one, then they would be like terms. So not like terms versus like terms. Be sure that you can identify those. Okay, so in our first example, what we're going to do is we are going to subtract two polynomial expressions. And so the one thing to remember when we are subtracting polynomial expressions is that with this negative sign in here, it has to be distributed through to all of the terms inside the parentheses. So here, there's no negative out front here, so we can just drop the parentheses on this one. And so we have 10b to the fourth plus 2b squared. But now this negative sign here, negative, so minus a negative 5b squared, minus a negative is going to become plus here. And minus 13b, so minus a positive, so it's minus. And minus a negative again is going to make this one plus. So we have to be very careful of the signs. But once we have distributed that negative sign, we got rid of the parentheses, now we can go ahead and combine like terms. So notice here we have a b to the fourth and a b to the fourth. So 10b to the fourth plus 8b to the fourth is 18b to the fourth. The 2b squared plus 5b squared gives us 7b squared in the middle. And there is no other term other than this one with an exponent of 1 on it. We don't have to write that in, of course, but it's there, so minus 13b. And so remember, we do need to classify it by degree and number of terms. So it is a quartic because it's a fourth degree, so quartic. There are 1, 2, 3 terms, so it is a trinomial. Okay, and the next one down, I did, since it's plus in the middle here, we don't have to worry about distributing a negative sign. So we can just drop the parentheses. But what I did is when I rearranged it, I put the parentheses back in so you could see what terms we were combining. So here, the negative 11k to the fifth, that's the biggest one out of here, and there's a plus 12k to the fifth here. So I just wrote it out, negative 11k to the fifth plus 12k to the fifth plus, okay, the next one down, there's no power of 4 in any of them, so we look here. This one has a power of 3, and it's the only one, so plus 14k cubed. And then, once again, no second degree here, but there is a one with a first degree, so 10k here and minus 4k here. So we're going to combine those. And then for the constants, we have plus 14 and minus 1, so 14 minus 1 here. And so now it's just a matter of combining like terms. Negative 11 plus 12 gives us 1k to the fifth plus 14k cubed. Here 10k minus 4k is, or I put an x there, that should be a k. So 6k plus 13. So this one, since it's to the fifth degree, it is a quintic polynomial. And there are 4 terms, so it's a quintic polynomial of 4 terms. Okay, moving on. This next example, we're going to look at multiplying some polynomials. So I'm going to use several different methods when multiplying these. Pick out the one that you like the best and stick with that one. So in the first one, and just remember the methods that we have talked about before are FOIL. We've used the FOIL method, we've used the box method, and we've used the vertical method for multiplying these. Okay, so here I'm going to use FOIL on the first one. So when we multiply 2x, f stands for first, of course, 2x times 3x is 6x squared. O is for outer or outside, so 2x times 3y is 6xy. I is for inside, so y times 3x, we can write as 3xy. And L stands for last, so y times 3y is 3y squared. And now we can go ahead and combine the like terms. So these are the only two like terms. 6xy plus 3xy is 9xy. So we have 6x squared plus 9xy plus 3y squared. Notice it does say to put it in standard form. Since all of these basically have a degree of 2, because here 1 plus 1 gives us 2 here, 2 here, 2 here, there really is no correct order to put those in for standard form because they all have the same degree for each term. So it's already in standard form as it is. Okay, next one. I'm going to use the FOIL, and it's really kind of the distributive property. That's what FOIL really is the distributive property. So when we multiply 5n plus 8 times 2n squared minus 5n minus 2, really what we're doing is when we do FOIL, we take this and multiply it by everything inside here, and then we take this and multiply it by everything inside here. So that's what I'm going to show what we're doing here. So take the 5n and multiply by all of this, 2n squared minus 5n minus 2. And then take the sign with this, so plus 8. And then it's going to be multiplied into 2n squared minus 5n minus 2. Okay, so when we distribute the 5n times 2n squared is 10n to the third. Remember, when we multiply with like bases, add the exponents. So n to the first times n squared is n to the third. 5n times negative 5n is minus 25n squared, and 5n times negative 2 is negative 10n. And then we can go to this one. 8 times 2n squared is plus 16n squared. 8 times negative 5n is minus 40n, and 8 times negative 2 is minus 16. Okay, so we have all of our terms here. Now we can just combine like terms. So look, there is no other cubed term, so it just goes out front. Negative 25n squared plus 16n squared. Well, negative 25 plus 16 is negative 9. Negative 10n minus 40n is minus 50n. And there's no other constant, so the minus 16 goes at the end. Okay, so there is two examples of using FOIL. We'll also look at an example here. We're going to use the box method on this one. So 3k minus 8 times 6k squared plus 2k minus 8. Once again, so I've already set up the box. So just write your bigger polynomial up here and then the shorter one down here. And now we're just going to multiply each box. Basically, in essence, what we're doing is finding the area of each of those boxes. So 6k squared and 3k, this would be 18k cubed. 3k times 2k would be 6k squared. And negative 8 times 3k is minus 24k. Okay, next one, 6k squared times negative 8 is minus 48k squared. Negative 8 times 2k is minus 16k. And the negative 8 times negative 8 is positive 64. Okay, and now it's just a matter of combining like terms. So there's no other k cubed terms, so we're going to write 18k cubed. Negative 48k squared plus 68k squared is minus 42k squared. Negative 16k minus 24k, well, that's going to be minus 40k. And then there's no other ones here, so just plus 64. Okay, so once we have all the boxes filled in, just combine like terms, and we're done. Okay, last one, multiplying vertically. So here, this is 2a plus 4 to the third power. Remember, we have to multiply 2a plus 4 times 2a plus 4 times 2a plus 4. This is not 8a cubed plus 64. That doesn't work. We have to multiply it out a little bit longer. So remember, in regular multiplication, we're going to start here and we're going to multiply by both of these. So 4 times 4 is 16. 4 times 2a is 8a, so 8a plus 16. And then 2a times 4 is another 8a. Remember, we're going to put 0 in here as a placeholder. And then 2a times 2a is 4a squared. And now we add it down. So 4a squared plus 16a plus 16. Okay, so what I'm going to do now is bring that over here. 4a squared plus 16a plus 16. And I'm going to multiply it by 2a plus 4. Okay, so we're going to do the same thing here as we did over here. 4 times 16, that's 64. 4 times 16, 16a is plus 64a. And 4 times 4a squared is 16a squared. Okay, next line, put in our placeholder. 2a times 16 is plus 32a. 2a times 16a is plus 32a squared. And 4a squared times 2a is 8a cubed. Okay, and now we add. So we have 8a cubed plus 48a squared plus 96a plus 64. So notice, just like I mentioned before, if we distribute this, we have 2a or 8a cubed plus 64. Those do show up in our final answer, but we do have these other terms in the middle here to worry about. Okay, so be very careful when you're multiplying these all out. Hopefully this is enough to get you going on that. If you have any questions, of course, you can ask. Thank you very much for watching, and have a great night.